Hey guys, we're back. Fred here from AF Math and Engineering, and we are about to solve the third and final part of this nail design question. If you recall, a couple videos back we were given this cross section here, and it was simply supported. It had a 750 pound load in the center. We drew the shear diagram, we found the moment of inertia, and then we calculated, which is what the question asked for initially, the shear force transferred by the nails from flange to web in a 12-inch length of the section. Okay, so we calculated that and we found that it was roughly 390 pounds. Okay, the final part of the question is asking us to find the spacing required for the nails. So what is the distance we need to space the nails apart from each other in order for the flange not to just shear off the nails in the web, okay? And it's fairly straightforward. You just have to think about it, to be honest, and reason it out. So it's quite a quick question, so I've gone ahead and just written it down so we can just go through it quickly. This will be a nice quick video. So number of nails. First, we need to find out how many nails we can, the very minimum number of nails that we can put into this beam without it shearing off, okay? How do we do that? Well, in the 12-inch section, we already found that the shear force being transmitted is roughly 390 pounds, right? And at the start of the question as well, if you want to go back and check it out, we were given that each nail can hold 50 pounds, okay, in shear force, okay? So that's the allowable shear force per nail, okay? So what we're going to do is we're just going to divide 389 by 50, all right? Canceling out the pounds here, we are going to get roughly 7.78 nails, okay? Now, obviously we can't have 7.78 nails. That doesn't happen in reality. So obviously we're going to round up, okay? We're not going to round down and have less nails because that's unsafe. This number of nails is the absolute minimum number of nails that we require. Okay, so in reality you'd want to put even more than 8, but for the sake of this question we're going to use 8, okay? So we need to actually look at what the question is asking though, because this isn't what the question is asking. The question is asking us for the spacing of the nails, okay? So depending on what the question asks for, so this question is asking about a 12-inch section of the beam, all right? If the question asked for the entire length of the beam, we would use 12 feet as our length instead of 12 inches. But the question asked for a 12-inch span of the beam, and that's what we're going to use, okay? So coming down here, all right, we are going to simply divide the distance asked for in the question, 12 inches, by the number of nails. And that is going to give us a unit of inches per nail, okay? And in this case, it's 1.5 inches per nail. So really, I mean, in this case, if you're trying to memorize this process for a test or something like that, just look at the units. Just look at the units, inches per nail, okay? Spacing required. And work with the units that you have to get the answer that you want, okay? Like here, pounds and divided by pounds per nail. Pounds are going to cancel it. We'll end up with nails, okay? So that's a good way of thinking about it. Really, really straightforward question, but definitely something you can expect in a course like Mechanics of Materials or Strengths of Materials. And it's good to practice, and this is one that you should really nail on the test and not make a mistake on. Thanks for watching, guys. Give us a like or subscribe if you enjoyed these videos, and stay tuned for some more.